Hello everyone, my name is Abdullah.
I'm Israel.
Afan.
Today we are talking about the DFA minimization paper by Volmar. This paper is providing an pseudocode that basically do DFA minimization, and it has a few main points, which are that minimizing the DFA, and we implemented this using C++, and this algorithm should reduce the complexity to n plus m log n.
So, like Abdullah mentioned, this paper the main focus is fast execution, not good programming styles. So, in the past, there have been many efficient algorithms for DFA minimization. One example of an algorithm is the abstract algorithm from the author's previous paper, which is the efficient minimization of DFAs with partial transition functions. This paper was published in SCIENCE 8. So, problems with traditional approaches is that they're just slow and they're complex. Like the speed is indicated there as in they take 0 nk log n instead of what we have now, which is, as mentioned earlier, 0n plus m log m. So to minimize, generally we remove unreachable states and non-distinguishable states from the DFA. And Afan is going to talk about our DFA that we have and describe the test data and present how the transitions work.
So the left-hand screen on this slide shows some of the pseudocode and code we found in the paper. We wanted to improve the readability of the code, and we implemented it, and it is shown on the right-hand screen, right part of the screen. This part shows the removal of the irrelevant parts in the DFA. This one shows how we tried to remove the unreachable states. And this one shows how we remove the states which could not be reached from the initial state. Moving on, in this slide we can see the test data that we will be using today to implement our code. It shows the original DFA and also the minimized DFA. As you can see, there's a lot of states in the first DFA, and by reducing those, we were able to minimize our DFA.
So I will put the data. The number of states is 5. Number of transitions are 7. Number of initial states are 0. The number of final states are 2. So I will put the transitions 0, A, 1, 1, A, 3, 1, B, 2, 3, A, 3, 3, B, 4, 2, B, 4, 4, B, 4. The first final states are 2. The second final states are 4. So the output has a minimized DFA because it has the number of transitions. The output has minimized DFA because the one is this number of transitions are 4. This number of transitions are 3. Do you have any questions?